you are. You just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
This diagram shows a simplified setup of our experiment. The current is represented in green, and it runs through the circuit in a counterclockwise manner. It creates a magnetic field that is marked in purple. A dot means the field or vector goes out of the page, while an X means that the field or vector goes into the page. To find the magnetic field around a wire, we use Ampere's law. So we draw an Amperean loop around the wire, and we have the setup of the line integral from 0 to 2 pi big R, and then the vector b dot dr, and we set that equal to mu naught I enclosed. Solving from the equation, we have that the magnitude of b is given by mu naught I enclosed over 2 pi r.
Lorentz force
Tells us that when a charged particle passes through a magnetic field at an angle, a resulting force.
The formula for Lorentz force
That we use is F equals I times L cross B. We will use the right-hand rule as follows. Point your thumb in the direction of the current, fingers in the direction of the magnetic field, and the resulting force comes out of your palm. The force is extremely weak. It is not enough to accelerate the projectile against static friction. But don't forget our hero, the magnets attached to each end of the projectile. These magnets also create a magnetic field. Let's take a look at the left side of the projectile. This is the side view of the magnet, with a source of EMF in the left direction and a current flowing to the right. The field points outward from the north poles and then curves around to the south pole. Look at the diagram for more clarification. The field goes through the current near the bottom of the projectile where it touches the rails. In the diagram, current goes to the right of the page and is only perpendicular to the magnetic field in the left half of the wheel. The field is into the page. Using right-hand rule for the cross product, we find that the resulting force is upwards only on the left half of the wheel. This produces a torque which rotates the wheel. This torque is the main source of acceleration for the projectile. Both applications of
Lorentz force
result in the projectile accelerating away from the source of EMF in our experiment.